Hey, rookie, hop in the truck. Welcome to today's explainer. Look, today we're untangling the totally messy reality of industrial networking on the plant floor. As a field engineer, I literally cannot tell you how many late nights I've spent just staring at a control panel at 3 a.m. Everything is physically plugged in, right? The green link lights are blinking happily, but absolutely nothing is actually talking to anything else. The downtime clock is ticking, management is pacing right behind you, and you're just looking at a mess of wires. Well, today I'm giving you the exact cheat codes you need to spot these common protocol mismatches out in the field, hopefully before they ruin your weekend.
So, you're going to hear guys on the floor say this all the time. Hey, they're all EtherNet, so they'll talk to each other. Listen to me. That is, without a doubt, the single most expensive assumption you can make when opening a control panel. Seriously, it turns into a $10,000 mistake incredibly fast. You see an RJ45 port on a motor drive, you see another one on a PLC, you run a standard Cat5e or Cat6 cable between them, and you just brush your hands off, right? Job done. But I promise you, they are not going to magically talk to each other just because they share a cable.
Now, the trap people fall into here is confusing the physical wire with the application layer. Industrial Ethernet handles the vast majority of new network connections out there today. But what is actually flowing through that wire? That's the real question. The physical layer, the standard wire and those little plastic RJ45 connectors, that stuff is completely interoperable. You can plug them in anywhere. But the application layer, the way the data is actually packaged, formatted, and exchanged by the brains inside the machines, yeah, that is absolutely not interoperable out of the box. Let's think of that Ethernet cable like a telephone line. It perfectly connects the call, right? But if a French programmable logic controller calls up a Japanese drive, well, they still can't communicate without a translator. They're basically just shouting different languages at each other over a perfectly good phone line. The wire just establishes the connection. The three dominant languages actually flowing over these industrial wires are EtherNet IP, PROFINET, and Modbus TCP. If a device is built natively for one of these, it will not natively exchange I/O data with a controller built for another. Period. I don't care how hard you push that connector in. Out in the wild, you're essentially dealing with the three kingdoms of industrial protocols. Whenever you walk up to a panel, job number one is figuring out whose turf you're standing on. You have got to know who governs what. EtherNet/IP, that's native to Rockwell and Allen Bradley. PROFINET is native to Siemens. And Modbus TCP, well, that's your vendor-neutral workhorse. Getting this wrong is exactly why so many integration projects just completely blow past their budgets. So let's break these down one by one so you know exactly what you're looking at in the trenches. All right, first up, if you crack open a panel here in North America and you spot a Rockwell PLC, EtherNet IP is almost always your path of least resistance. It applies the common industrial protocol directly over standard Ethernet. The entire I/O tree, the device catalog which uses those EDS files, the diagnostics, it's all natively built right around it. And hey, here's a pro tip for you. If you see devices wired in a loop without a central managed switch, you're probably looking at DLR, or device-level ring. It's a specific setup that lets the network survive a single cable break, and it is a massive dead giveaway that you're deep in Ethernet IP territory. Now, let's say you cross the pond, or you open up a European-built motion cell. Boom, you are stepping into Siemens territory. This is where PROFINET's strict timing and GSDML files absolutely rule the roost. If you bid up your laptop and launch TIO Portal, you're in PROFINET country. Now, the big thing you need to watch out for here is the timing. PROFINET RT handles your standard cyclic I/O with soft real-time. But if you're dealing with coordinated motion, like robotic arms or really high-speed synchronization, you're looking at PROFINET IRT. That stands for isochronous real-time, and it delivers hard deterministic timing. It's incredibly fast, but man, it is unforgiving and has very specific network expectations. And then we have the granddaddy of them all, Modbus TCP. Tracing its roots way back to 1979, this is your universal common denominator workhorse. It is built on this beautifully simple client-server model. The client polls, the server answers, and the server literally never speaks unless it's spoken to. You don't even need a complex device file, just a basic register map. So when you're staring at some mixed vendor Frankenstein machine or you're trying to pull legacy gear onto a modern Ethernet backbone, Modbus TCP is usually your lowest risk, easiest path to getting things talking. Okay, so here is your veteran mental checklist for spotting mismatches the second you crack open an unfamiliar panel. Step 1, look at the CPU. Is it Rockwell? Instantly default your brain to EtherNet IP. Is it Siemens? Default to PROFINET. Step 2, verify the device files in your software.
Like, if you have a PROFINET controller but you're hunting for EDS files instead of GSDML files, yeah, you've got a mismatch and it's not going to work. Step 3, check the timing needs. Does the application need hard determinism for motion control? Because if it does, Modbus TCP just won't cut it, and you'll need PROFINET IRT. But what happens when you actually have to mix them?
Because let's face it right, in the real world, most plants are running more than one of these protocols at the exact same time. You might have a line with PROFINET in the Siemens cells feeding right into EtherNet IP on the Rockwell packaging lines. When you absolutely need these different ecosystems to talk to each other, you don't force it. Instead, you bring in a diplomat. You use a multi-protocol controller or a protocol gateway. Trust me, you never want to try and force one protocol onto every single device. It's a battle you will lose, and you're just going to waste hours pulling your hair out over software configurations. And this is exactly why a multi-protocol controller like the Wago PFC200 family is basically the Swiss Army knife you want in your truck. Take a model like the 750-8216. It natively speaks multiple languages at once. It handles Modbus RTU, Modbus TCP, acts as an Ethernet IP adapter, and it can even talk to EtherCAT and CANopen, all at the same time. If you step up to the 8208 model, that one adds Profibus master capabilities, which is huge because it means you can pull decades-old legacy field bus devices right onto your modern Ethernet network without breaking a sweat. It just translates everything seamlessly. Now, what if your PLC is remote and you just need remote I/O out in the field? Well, you absolutely must match the Fieldbus coupler perfectly to the native protocol of your network. The cleanest way to guarantee that compatibility is by using a modular I/O backbone, like the Wago 750 system. The real beauty here is that you don't have to rip and replace your entire I/O rack if the network changes down the road. You use the exact same I/O modules and you just snap on a different head, the coupler. Running Ethernet IP? Snap on the 363 coupler. Need PROFINET? Grab the 375. Need that vendor-neutral Modbus TCP? The 362 is going to be your go-to. It's that simple. All right, listen closely to this next part because I see it cause endless headaches in the field. The absolute fastest way to ruin a perfectly good plant network is to throw a cheap $50 unmanaged switch from an office supply store into a complex setup. Don't do it. It will instantly strip away critical PROFINET diagnostics and timing features. Carrying multiple protocols on one backbone is exactly where managed switching earns its keep. A solid managed switch gives you VLAN segmentation, rapid spanning tree protocol for redundancy, and traffic prioritization. That last one is huge. It keeps your critical deterministic traffic completely separated from, some guy downloading a PDF manual on the general network. So instead of that cheap, unmanaged brick, you really need purpose-built hardware, like a PROFINET-rated managed switch. These things handle stuff like LLDP topology discovery, which is absolutely required to keep chaos off your network. LLDP, or Link Layer Discovery Protocol, is a massive part of what makes PROFINET actually function correctly. If you use an unmanaged switch, it literally just drops those LLDP packets into a black hole, totally blinding your PLC to what's actually connected to it. Hardware like the Wago 852-1605 is built specifically to handle these PROFINET segments safely. Because if you get this right, it means absolutely everything. With the proper managed switch infrastructure and VLAN segmentation, just one single physical backbone can safely carry multiple protocols without crossing the streams. Physically, they can absolutely share the wire. They can coexist on the same cabling and the exact same managed switch. But think back to our earlier lesson. Application-wise, they still will not exchange I/O data with each other unless you have that multi-protocol controller acting as the bridge. So get the physical infrastructure right, segment it properly, and then deploy the right gateways to translate the languages. So, as we wrap up this explainer, I want you to do something. The next time you walk up to service a control panel, don't just look at the blinking green lights on the RJ45 ports and assume everything is fine and dandy. Ask yourself this crucial question. Are these systems truly communicating, or are they just wired together in silent isolation? You gotta understand the ecosystems you're working in, respect the massive differences between the physical and application layers, and use the right managed hardware to bridge those gaps. Do all that, and I promise you'll never be fooled by the RJ45 Illusion again. Catch you on the next one.